The problem: a standard size shaft and a tapered hosel, it doesn't fit correctly. We need to do something to fill up the space that is causing this sloppiness in the fit. One method would be to put tape on the hosel, but that's not a perfect fit. Because tape is soft, it kind of comes out the end a little bit, and what I've found in my shooting and passing, there's a little wiggle room, and it leads to inaccuracies. So let's take off the blade and do another method. The plan is using the epoxy method for a perfect fit. I want to be able to shoot like this again. But like Mike Tyson once said, everyone has a plan until they get punched in the face. So I'm going to use sandpaper to make the inside of the shaft rough so it can accept the epoxy. And I'm going to clean it with rubbing alcohol. Now also I'm going to put a plug into the shaft so the epoxy doesn't drip all down the shaft. I'm going to use water to get the displacement so I can see approximately how much epoxy I need. And I'm going to put plastic wrap around the hosel so it doesn't stick to the epoxy. I'm also going to use masking tape so the epoxy doesn't drip all over the shaft. And I'm going to pick between the plastic bonder or steel stick. As you can see, I cleaned the hosel very nice and the shaft. I used rubbing alcohol, and I also used a product called Goo Gone, which removes all the residue of the black tape and all the stickiness. And now you can see the problem still is there's too much wiggle room. But we're going to fix that with the epoxy method. Now the next step in the plan is to use sandpaper, 500 grit, and it's going to roughen up the inside of the shaft so the epoxy will be able to stick better, because if it's a smooth surface, it may not stick as good as one that's roughened up a bit. As you can see, that's how it looks after. Now we're going to stick the plug in this, just so if I put epoxy in there, it won't run down to the top of the shaft. And there's the after shot of that. And now I'm going to pour a little water in there and then stick the hosel in, and there will be a displacement of water. Obviously, that's the approximate amount of epoxy I need, just as an approximation. Plan A, I'm going to put plastic wrap, but it's going to be rejected later. You'll see. Seems to be okay, fits nice. So then I put masking tape around the shaft for any dripping epoxy. But now I notice there's a rip in the top of the hosel of the plastic wrap. So that's not good. That's not good. So I'm going to go to plan B, masking tape. But I rejected this because of my bonding fears. I thought it might bond permanently to the shaft because of the edges seem to have some exposure. Plan C, the thumb of a rubber glove. I accepted this because, as you see, I put the rubber glove, the thumb actually, over the hosel, and it creates a nice barrier so that the hosel will not stick permanently to the shaft, but I will be able to remove it in theory. Now I wanted to do some experimenting with the epoxy, so I poured some into a bottle cap, and I put 3 little toothpicks in there, and you can see the impressions. And you see the epoxy is pretty flexible, so that's a good thing. It's not brittle, it won't break, but yet you can hear that it's very hard. So I think this is perfect. And I also put it on a little bit on the glove to see if it would interact with the rubber, but it looks good. It went on nice and smooth, and I checked the back to see if it went through or anything, but that's fine. So we'll also test how much flexibility. Oh, a lot of good flexibility here. But let's check the hardness again. Oh, very hard. This should be a very nice epoxy. And I'm going to use JB Weld plastic bonder for composites. So let's squeeze it out. It's a two-part epoxy, so it needs to be stirred. And then the chemical reaction starts, and it has 15 minutes before it sets. So I have 15 minutes to work with it. And what I'm going to do is I'm going to use a little bit of a credit card and mix it up a little more, and then start applying the epoxy inside the shaft. And I did put down some plastic, and you can't see it there because of the camera angle, but I assure you I don't want that on my carpet. So, so there you go. I'm putting the epoxy, approximately the same amount I predicted I would need, into the shaft. And I'll get the last bit in there, and now I'm going to stick the shaft in there, and then I'm going to let it dry for a day. So there it is drying on my patio, and it was about 90 degrees that day, so that's a good thing. So I already got it started a little bit, and it pulled out fairly easy. It was tight. I mean, that's, pardon the pun, but it fit like a glove. And as you can see, the blue glove finger is actually in the shaft. There's a before and after shot. And I put together the stick again with regular hockey glue. Now I will go to the rink and test out the stick with the epoxy. I'll be predominantly going for the top shelf. The stick has good feel. The puck is going right where I want it to. Let's do a couple top shelves here. Right shelf, left shelf. Now I'll do a few backhands. Not specifically going for the top shelf, just trying to be accurate on the left side of the goalie. Okay, now let's try some beaking around the cones just for feel of the stick and puck. And it's handling really good. Let's try a different angle. So I go hard left, then I cut back inside right. That's the way to go around pylons. Okay, so after the skate, I heated the stick up again and tried to remove the hosel from the shaft. And I mean, as you see, it took quite a bit of force to get that out. I mean, I don't want to say it, but it's fitting like a glove. And I really didn't need the hockey glue. So here's all my shafts. Thanks for watching the video. Here are some lessons I learned to help in future projects.